All right, well, shall we get started? Let everybody straggle in a little bit after. Are there snacks out there? Afternoon snacks out there now? I didn't see. Okay. Well, let's talk a little bit about migrating legacy ASP.NET applications gradually. So, as probably most of you know by now, .NET, modern .NET, as you might call it, or .NET Core, has been out for 10 years. And yet, there's still a lot of code out there, a lot of legacy code that's still running on what you might call .NET Framework. We'll talk a little bit about these terms as we're getting into the discussion today. But a lot of that code still exists out there. At my company, Trailhead, we still get a lot of our clients that come to us asking for us to help migrate those legacy applications. From the fact that you're here today, my guess is that you probably have at least one of these that you're thinking about migrating or in the process of migrating right now. Of course, there's tons of advantages of migrating a web app to .NET Core or modern .NET. And the advantages, of course, are the number one is performance. You probably have seen some of the stats about this. Modern .NET, ASP.NET Core are going to be a huge upgrade for your code without really making any other changes to it. So there's a huge advantage there. Obviously, modern frameworks, modern libraries, all of those things that you get out of the box with ASP.NET Core as well. The problem is that when you're migrating .NET code, it's very similar between .NET Framework and .NET Core. But when you're migrating web code, there's quite a few changes. The middleware or pipeline for ASP.NET Core is quite a bit different than it is in ASP.NET. And you've got things like dependency injection, you've got things like the configuration framework, you've got things like the retirement of certain UI frameworks like web forms. All of these things kind of add up to ASP.NET to ASP.NET Core projects are probably the hardest category of projects to upgrade. So today we're going to be talking about that, and I actually want to show you how you're going to be able to upgrade your projects gradually from legacy.NET to modern.NET. So that's what we'll be talking about today. My name is Jonathan Tower. I go by Jay for short. As you can tell from my accent, I'm from the US. And a little bit about me on the side here. I'm a 10-time recipient of the Microsoft MVP Award, always in .NET, although most recently I've submitted for that to also be in Azure AI because I've been talking a lot about Azure and Azure AI recently. You can contact me at these places online. I host a podcast where we talk about things like YARP and other things that we'll be talking about today. And then the last two things I want to mention on the side, first of all, at the bottom, I see some of you taking a picture of this already. There's a GitHub link, which I'll show again at the end, where you can get all of the slides and code that we'll be looking at together today. And then the last thing I want to mention is that sometimes people will ask really great questions at the end of the talks. Happy to do that if you want to come up, if you want to raise your hand if we have time left over. Happy to do that. But also sometimes there's something that involves getting into a little more detail, some specifics of your situation, maybe an NDA. All of those things are possible if you want to contact me using this QR code or bit.ly link on the right-hand side of the slide. This is an offer I give to just people who come to any of my talks. If you want to connect afterwards, totally free of charge, and just ask about anything. I'm happy to talk about anything, presumably software related, but broadly if you want as well. So before we jump into the migrating part of it, I just want to make sure we have some terms consistent here. My hope is that if you're all .NET developers, these are all rock solid in your head already, but may surprise you that a lot of people familiar with and using .NET are still trying to wrap their head around what the differences between all of these different things is. And we're going to be talking a lot about .NET Core, .NET Framework, modern.NET, legacy.NET. And as I'm throwing these terms around, I want to make sure we're all thinking about the same thing. So I created this slide to kind of illustrate the history of .NET, if you will. You've got the blue line here, which is .NET Framework. This is the classic .NET that's been around for over 20 years, 25-ish years at this point. Started in about 2000, 2001. It's the one that's baked into Windows. It only runs on Windows unless you're using something like Mono. And in about 2019, the last minor version release, 4.8, came out. And now Microsoft has basically said, since 2019, no more updates, no more major updates to this will happen, no more new features, no new development of any kind. Really only just support releases, security patches, that type of thing is going to happen to framework. So we've known that for now about 6 years. During that same time frame, about 2015 or so, .NET Core 1.0 came out. The idea of .NET Core, I think from a branding perspective, was we're going to go back to the core of .NET and start over. They rewrote .NET Core from scratch. It's now totally cross-platform, runs on Mac, Linux, Windows, not just IIS for ASP.NET, but any web server that you want to run it behind. Any cloud, Docker containers, all of that stuff is now supported more natively. So that happened in 2015. And then right about the time, 2019, when Microsoft announced that 4.8 was going to be the last major minor version of .NET Framework, they also said if 4 is where .NET Framework stops, then going forward, .NET Core, we can simplify and just call it .NET. This is the future of .NET. It is the only .NET. So to confuse things, now we've got this modern .NET thread here that's yellow and green. That's both .NET Core and .NET. And when we're trying to distinguish between the two, just saying .NET isn't super clear. I'll often say modern .NET or just .NET Core. And we'll be talking about that whole modern .NET thread of yellow and green. And then if you hear people say .NET Framework, full framework, or just framework, those are usually ways to refer to this blue thread or this legacy version of .NET. The other thing to talk about is, since we're talking about web applications and upgrading them, is ASP.NET and ASP.NET Core and what the differences between those are. The version of ASP.NET that's been around since 2000 and includes things like web forms is the one that runs on .NET Framework, Windows only, IIS only, the system.web namespace, all of these things. This is ASP.NET or ASP.NET for short. And then in 2015, ASP.NET Core came out. And of course, at the time, Microsoft wanted people to be able to easily migrate these applications and knew that some organizations would be slow to adopt .NET Core on their servers or cloud systems. And so they basically made the first few versions so that ASP.NET Core could run on .NET Framework or .NET Core. Then eventually it made sense to stop that support, and you've got ASP.NET Core now running since version 3.0 only on modern .NET. So just to confuse things, you don't have to always run ASP.NET Core on .NET Core or modern .NET, but what we're going to be talking today is mostly about ASP.NET applications running on .NET Framework that you want to upgrade to ASP.NET Core running on modern .NET. Okay, so let's talk a little bit about how you can approach this. In the title, I talk about doing this gradually. Part of the reason why that's so important is because there's obviously different ways to approach this. And because ASP.NET projects are particularly tricky, you don't want to approach this the way you might do a simple console application or even Azure Functions upgrading from one version to another. These are all things that you could do potentially in a short time frame. Any large or complicated application that's a web application, ASP.NET, is going to take some time to migrate. And because of that, you're going to want to use a gradual approach. So there's a couple different approaches that you might be familiar with. If you've ever been part of a big bang approach to a migration, you might recognize it by the fact that you were locked into a conference room and you weren't allowed to come out until the migration was done. You know, usually it's some sort of an environment like that. Maybe someone slid pizzas under the door to keep you fed. Usually these don't go really well unless it's a very, very small or insignificant application. The more common and recommended way that is much more agile to do this would be the Strangler Fig approach. I love talking about the Strangler Fig approach when I'm in Australia because it actually comes from a plant that you all have endemic to Australia that is colloquially, easy for me to say, known as the Strangler Fig. It starts growing in the branches of the tree. Typically it would be dropped by a bird or something like that into the branches. It'll start growing as a vine down towards the ground. Eventually it'll reach the ground and it'll start wrapping around the tree's roots, around the tree itself. and start sort of choking the tree off from the resources that it's getting from its own roots. Eventually, this will kill the host tree and just leave the host tree there as a backbone, helping this Strangler Fig plant reach up into the canopy and get the sunlight that it needs to photosynthesize. So this is a kind of slow motion, violent example from nature of how one thing can gradually replace another thing. And there's an architectural approach that's also called the Strangler Fig that's inspired by this. So in a typical Strangler Fig approach, you're going to have what's called a facade layer. This will basically be a layer that you put in front of your existing application and used as a way to bring together the two applications behind it, the modern and the legacy application. Eventually, at the beginning, your legacy application will start out with the vast majority of your functionality in it, and your modern application will start out essentially empty. Over time, you'll start to move functionality over into that modern application, removing that same functionality, retiring it from the legacy app, and using that facade layer to make it so that your end users, whether they're using APIs or whether they're using a web user interface, to make it so that the users are none the wiser about any of those changes. And then eventually you finish moving all of the functionality over and you've now got a completely modern application. That is the theory of how this works. What's great about that is throughout the process you can actually release applications. So it stays a very agile approach. You're not essentially doing a backdoor approach to the Big Bang type of a project where you basically are doing small iterations but you can't release it until the whole thing is done. The idea of the Strangler Fig approach is that you can release as you're going. So let's just talk a little bit about reverse proxies, because that's what we're going to be looking at with our examples today and how they work. Anybody like me old enough to remember proxy servers as a way to access the internet when you're on a network? Yeah? Okay. It's nice to see some fellow gray hairs in the audience with me. So this is what a forward proxy or just a traditional proxy server would do. You'd have clients on a network. They would hit a single proxy server. You might remember in the old days in Windows, you'd go into your network settings and configure an IP address as your proxy server. And that server would be the only one on the network that would have an internet connection directly. And it would basically proxy your requests out to the internet, receive the requests back, and then send them back to you, the client. So that one server would be typically pretty busy. But that's how a forward proxy works. So a reverse proxy, if you just switch the order of these two middle bits and you put the internet and the proxy server on the opposite side, now you've got traffic coming in from clients over the internet, hitting first a reverse proxy, and that proxy is sort of protecting the servers that are running behind it and is looking at that traffic and deciding which server goes to based off of anything. It could be round robin, it could be based off of things in a cookie or in the request itself. So that's kind of what a reverse proxy looks like. As you can imagine, with this type of a setup, you could use these for lots of different things, not just incremental migrations. I've seen them used successfully for A/B testing if you want to roll out a couple of different options for a feature and see which way your users enjoy interacting with it the most and gather some data. You can do that. Just simple URL rewriting. If you have complex URLs, you want to simplify them or pull together multiple systems so that they look like they're one system, you can do that with a reverse proxy. Sometimes they'll be used as a security layer in front of an application. One of the ways that they're used like that is when you're doing microservices architecture. You typically want to have some sort of an API gateway that'll be doing things, cross-cutting concerns like logging, security, for example. Another one is feature flags. If you want to turn on certain features for certain different deployments, you could say if a client is coming in through this subdomain, clientname.mydomain.com, then you could turn on certain features for certain users that way. And then the last one, which is the one we're going to be focused on the rest of this time together we have today, is incremental migrations. So let's now talk about a very specific reverse proxy, one called YARP. Anybody in the audience already familiar with YARP? Okay, a few of us, yes. Most of us no. So it sounds like you're in the right place. So if we look at that simple example I showed you of how a reverse proxy works, now we're showing a more complex example of that kind of zooms in to each of those layers of the application. So you've got clients calling in, and they're hitting an ASP.NET Core application. So this would be a modern .NET web application. And you can see in the request response pipeline, there's two things in here. Now, it doesn't have to be MVC, but I've shown an example because I think most people are the most familiar with MVC. So I've got MVC in my request response pipeline or middleware. And then in front of that, I have something called YARP. YARP stands for Yet Another Reverse Proxy. Very creative naming from Microsoft. And that is actually added as a NuGet package and then installed into your middleware in front of whatever web framework you're using, in this case, MVC. Now, when a request comes in from a client, it'll hit YARP first because it's at the top of the stack. And YARP will look at something that has been around from the very early days of ASP.NET. In fact, the first version of ASP.NET had this. It's called the routing table. Most of the web developers I know who are in .NET aren't even really aware that this exists consciously. But basically, any application that you have is going to register, any ASP.NET application you have is going to register all of its routes with this routing table and say, I can respond to any of these things. And then if someone tries to hit any other URL in your application, they'll get a 404 handled by ASP.NET itself, or ASP.NET Core in this case, if that is not in the route table. So it's going to go look at the route table and say, do I already have a route registered in this modern ASP.NET Core application for this particular request? And if the answer is yes, then it's going to go ahead and forward that down the middleware pipeline and let that be handled by whatever particular framework has registered that route, in this case, MVC. So MVC, as you know, will then use a controller class to handle that request. So that's how it works when it does find it in the routing table. How does it work when it's not in the routing table? Well, the request will come in and look at the routing table, and this time it won't find this URL in there. And now YARP will be configured by default. You can configure it however you want, but the default configuration will say if it's not in the routing table, forward it onto some proxied server behind. So this will be your legacy application. So basically, does the URL exist in this application, the modern one? No. No problem. I'm going to forward that behind to the ASP.NET legacy application, and that is going to handle that internally with whatever tech stack it's using, and that request or response is going to then get proxied back through the ASP.NET Core application back to the user. So whether someone's hitting a URL that has been migrated or hasn't been migrated, it's getting handled either by the modern or the legacy application. So that's basically how YARP works. Now, I think you can probably see the pattern here and how this maps to the Strangler Fig. So in the Strangler Fig, we had three pieces, right? We had the facade, then the legacy and modern application behind it. In YARP configurations, we're going to basically have only two pieces. The modern application, which has YARP at the top of its pipeline, and then whatever it wants behind that to play the role of the modern application, YARP playing the role of the facade. And then the only other thing that's deployable here is the legacy application. So you might be asking, okay, I've heard of YARP now, but there's already all these other reverse proxies out there or web servers that can be used as reverse proxies. Why would I want to use YARP specifically? And the answer basically comes down to a combination of a few things. Number one is it's got fantastic performance. It's been written in a way to perform extremely well. So if you're worried about what is proxying all these things through my modern application, going to slow my application down very much, the answer is obviously not zero, but it won't slow it down very much. It's very quick. The next one is it's super easy to use if you're a .NET developer already. You're just going to pull a NuGet package into your modern ASP.NET Core application. You'll write literally a couple lines of configuration code, and you're up and running on YARP. The other one is it's extensible and configurable. I was actually just talking to one of the other speakers here at the conference earlier today who used this as a way to migrate from not an ASP.NET, but even older application. And they had custom subdomains for all of their clients. And they were able to extend YARP and write their own business logic in there to say, if it's this client, look it up in the database and forward it to this new system. Otherwise, if it's this other client, look it up in the database and find out that they're on the legacy system still and forward it there. So pretty cool. You can literally write whatever logic you want into this application and have the routing work based off of that. So totally customizable with hopefully something you're already familiar with, C# and .NET if you're a .NET developer. And then the last one is something that I showed you on that last diagram. Typically, when you use a reverse proxy, you now have three resources to worry about: updating, configuring, and managing, which is your reverse proxy, your legacy application, and your modern application. One of the cool things about the way YARP works is it runs high in the pipeline of your modern application. And so now you only have two things, the modern app and the legacy app, that you have to worry about creating resources for, maintaining, deploying, etc. So it makes it a little easier by, a third less work. Lots of examples of things, just to kind of give you a broad picture of what you could use this for. Lots of things that I've seen it used for. Obviously, because YARP is a .NET technology, I see it used primarily by people who are already familiar with .NET, maybe to move some legacy .NET thing like web forms or ASP.NET Web API running on .NET Framework or something like that, to something more modern like ASP.NET Core that's in the .NET space. But what's interesting is you'll notice I've got PHP over here as an example of something you could migrate from. Because YARP is a reverse proxy, it doesn't matter what the legacy application is. If it speaks HTTP, it can be migrated from to something in modern technology. Now, because the modern application, in the case of YARP, the modern application is expected to be running inside the same application that YARP is running, you typically are going to want to target moving to a .NET-based technology as your target. But you can see on that left side, it could be anything. So if you have old Java JSP pages, or if you have PHP or some classic ASP, all of those kind of like super old web technologies that you want to move to a modern .NET technology, that's a pretty good candidate. If it's something ASP.NET running on .NET Framework, it's a fantastic candidate. So just to give you a few examples of some of the things that I've seen or helped with, moving from a legacy MVC application to a Blazor client-side or Blazor WASM application with a ASP.NET Core Web API running behind that is something that I've seen done. Another example would be moving from that same type of a setup to a Blazor server application. I've even seen quite often moving parts of the application into an API layer and then moving other parts of it into a JavaScript SPA application. So that's also possible. And I thought it would be interesting to write a blog post about this and show kind of a simple, somewhat trivial, but enough to get you started example. And so I've got this bit.ly link here with a blog article that I actually wrote. This is moving a ASP.NET Web Forms application to a Blazor client-side WASM application. And I don't take you through 100% of the process, but I take you through enough of the process in this blog that you can get an idea of kind of how it would work and what steps you would need to do to continue the process for your obviously less trivial real-world application that you'd be doing it with. And that's the sort of thing, too, if you read that and think, I sure would like to talk more about this, that if you want to reach out to me with that QR code, you'd be welcome to do that, and we could talk about that in some more detail. So another tool that I think would be helpful to talk about in this conversation is the .NET Upgrade Assistant. Anybody already use the .NET Upgrade Assistant or familiar with it? Ooh, okay, even fewer hands than with YARP. So I'll be showing this to you in just a moment, but first I want to just talk about it. This is two different things. It's a Visual Studio extension and it's a .NET CLI tool. So you can do this either way, whether you like to use Visual Studio or if you're more of a VS Code type of a developer and you want to use the CLI, you're welcome to use it either way. I'm going to show you examples today using Visual Studio. But this helps you basically walk through the process of upgrading all kinds of different things. So if you're doing .NET Framework to any kind of modern .NET, .NET Core to .NET, or any version of .NET to a newer version of .NET, all of those types of things, as well as Azure Functions, Xamarin Forms to MAUI, all of those types of things are things that it can help you with. Console applications, class libraries, and ASP.NET obviously is one of those types. So here's the types of projects that it supports right now. You'll notice one that's kind of an outlier, interesting outlier here, which is WCF. Anybody who's still using WCF and willing to admit it? All right, still quite a few of us. So you may or may not already be familiar with the core WCF project, which is an open source implementation of WCF on ASP.NET Core. This could be a really great opportunity for you to be able to, without having to rewrite all of your endpoints from WCF to REST or some other newer thing, to basically port it over and get all the advantages of ASP.NET Core and .NET Core and running your same code much faster on the same hardware than you were before. So that's something worth looking into, and actually the Upgrade Assistant can help with that as well. I also just want to mention before I show it to you that back in November 2024, just several months now before we're talking here today, Microsoft announced at .NET Conf that they're working on a new version of the .NET Upgrade Assistant that is going to have some Copilot AI features built into it. So we'll look at an example here with this upgrade option just above the one that's selected. But in the future, there will be a version of this that comes with this upgrade with GitHub Copilot option. And you'll see that the UI we look at in just a minute will look a little different than this. But this is basically going to give you some suggestions. And you can see this button here up in the top right says Create Upgrade Plan. So that's a future feature where it's basically going to say how many issues and how many incidents of those issues are there in your code. So incidents just means how many times do those different issues happen throughout your code. So it might be like you're using this library and this library isn't supported anymore in .NET Core. And you used it, this many times. That would be an example of one issue with many incidents. So it'll give you a plan. You can then read through that plan. It will also then help you fix those issues using GitHub Copilot. So pretty cool future feature here. Because this process is so manual and so difficult, this will be a very helpful feature, I think. Not magic, obviously, like anything you've used in AI so far. If you don't know what you're doing, you can get yourself in trouble. But very helpful if you kind of know what you're doing, but you need a little step-by-step guidance through the process. So very excited about that. Coming at some point in the future. It hasn't been announced exactly when yet. I think it would be exciting if this was in November with the new version of .NET, but we'll see. So let's actually do a demo where we're doing an upgrade here using the .NET Upgrade Assistant to upgrade a legacy web application using YARP. All right, so I'm going to leave my presentation here, and we'll go over to Visual Studio. Everybody always asks me, how are you running Visual Studio on a Mac? So I'll just mention that I'm using Parallels to do that if you're interested. Also, this application has a SQL Server instance running. This is an old legacy store app, demo store app that you might have seen years ago that Microsoft created, and we're going to upgrade it together. So let's just look at it and see how it's working in legacy mode here. So the first thing I want you to draw your attention to is just this port number here. It's not important that you memorize this. Just remember that it's a 50,000 number. It's a 5-digit number. You're going to see in a minute here when we actually set up YARP that we're going to get a different port number than that for our modern application. And you'll be able to see that even though we're going to a different port, we're going to be getting the same basic application. So it's not the prettiest application in the world, but I can go in here and I can edit my items, I can create new items, all of that stuff works in here, and there's that SQL Server which I have running in a Docker container behind this to actually store all of that state. If we kind of close this and just look through the application real quick, I want to show you one thing that I did to kind of specialize this a little bit. You'll notice I have a class library here, and I have a simple class that just goes and you pass the HTTP context to it, and it goes and it gets a request header out of there for the user agent and returns that as a string. Obviously a pretty trivial example here, but I wanted to show you two things with this. Number one, I wanted to show you how it works to upgrade a class library, because probably your complex web applications have a lot of class libraries, and that'll be one of the first things you need to upgrade before you can upgrade the web application that's using it. The second thing I wanted to show you is if we actually look at where HTTP context comes from, you see that namespace, system.web. Does anybody know any problem with using something from system.web in a modern ASP.NET Core application? Yeah, that's right, yes. Fantastic. The answer was it's no longer supported, and that's correct. So everything in system.web, which if you think about it, that's the request, response, session, all the security stuff, the HTTP context, which owns a lot of that. All of that stuff is not gone, but it is moved, because system.web was written in such a way that it was married to IIS, the web server for Windows, and all of that stuff had to be completely rewritten for ASP.NET Core so that it wasn't tied to IIS, so that you could run this on any platform, not just on Windows. And because of that, any code that you have that relies on system.web namespace has a bit of a problem, and I'll show you what the solution to that is, and it's pretty simple to do. But I wanted to show you that. And just to use that somewhere, I wanted to create this new controller here. And you can see this new controller basically just sets a user agent property of the view bag to the results of calling that class in that other library project and passing the HTTP context to it. And then if we look at the view for that, obviously this is a web MVC application. So if we just look at the view for that, it very simply is just displaying that viewbag.userAgent property. So if we run this one more time real quick, we can see that if I go to /systemweb, that I'm going to get a very simple page with the layout of my application, the MVC layout, and I'm going to see the user agent here for my particular browser. So pretty simple, but it's using a class library, it's using system.web, and so that's the part that I wanted to show you. So let's go actually look at upgrading this. I mentioned the first step that we're going to have to do to upgrade our project is not actually the web application, it's some of the code that it references. So you'll notice here, I've got two projects. I've got my MVC project, and I've got my utilities class project. And if I go look at this, you can see it's a class library. It's currently built on Framework 4.8. Just for kicks, let's go look at the legacy MVC as well. And here we can see that this is also built on 4.8. So everything here is running on .NET Framework. And that's actually why I need to have parallels on this Mac that I'm showing it on, so that I can actually run .NET Framework. Though there is one version of Framework 4.8 point something that will run on the Mac as well. But I've got this running in there. So let's go ahead and start with this class library. So I'm going to come over here, and first I want to show you that I've got this extension installed. So I'll go to my extensions here, and under installed, you can see I have the .NET Upgrade Assistant already installed. I mentioned this is also a tool you could have as part of your .NET CLI. But this is where you'll want to make sure that you have it in your Visual Studio install if you want to use it inside of Visual Studio and see what I'm about to show you on your own Visual Studio. So I'm going to go to this class library first and right-click on it. And once I have that extension added, I'm going to have an option right here called Upgrade. So I'm going to click on that. You can see I get a number of choices here. The important thing to point out is that the first set of choices is basically my upgrading to a newer version of .NET, which is what I'm trying to do. And you can see I can get in place, side-by-side, or side-by-side incremental project upgrade. So normally what I would recommend is if this is a complex class library and you think it's going to take some time, you probably want to do a side-by-side project upgrade. This gives you a chance to have both of them in existence at the same time. Now I know this is a pretty trivial class library, or maybe I'm just feeling gutsy because I know I have Git and I can just roll back if this doesn't work, right? So I'm going to actually pick the in-place upgrade right here. And then also I'll just point out there's a couple of other options here. I can change to a central package management style of NuGet package. That's where your NuGet packages are all managed in one place for the whole solution. And I can also convert my projects to SDK style project files, both of which would be great modernization things to do. But it's not really the focus of this talk, so I'm going to focus on these first types of upgrades here. So I'll click an in-place upgrade. Now obviously .NET 9 is out right now. .NET 10 will probably come out in November, but .NET 8 is the long-term support one, so a lot of times we find our clients are aiming at the long-term support versions. Those are typically supported about twice as long as the standard support. So I'm going to go ahead and pick the .NET 8, not .NET 9. And then this last step will just kind of show me what files do you want to upgrade, and I'm going to say go ahead and upgrade everything, so I'll leave everything selected. And now you'll see the Upgrade Assistant is actually going through a process step by step with each of the references, with each of the class files that are in here. And it should actually complete here in just a moment. Okay, and you can see that basically if we scroll down, that I get all green check marks, so everything worked as you might expect. Everything was pretty simple in this class library, so there wasn't a lot of problems. This is where you, in your more complex class libraries, might have some NuGet package problems where you have to figure out what to do with a NuGet package that doesn't exist anymore, or that doesn't have a modern version or something like that. But because we have a trivial example here, we were able to upgrade that. Now if I go back to the project properties for this, you'll notice that this is now a class library upgraded to .NET 8. So this is great because now I have some class library that's running on .NET 8, but it's a little bit of a problem because if you think about it, I'm going to have both a legacy ASP.NET and a modern ASP.NET Core application running in parallel with each other that are both probably going to need to reference this for a while. And so does anybody know what the solution to that is called in class libraries where you can compile it in such a way that it's accessible to both ASP.NET and ASP.NET Core? Anybody from it? It's not quite multi-target. That would be more for like a NuGet package, but it's that concept. A .NET standard is correct, yes. So this one really throws people off if they're feeling a little fuzzy on some of the naming conventions that Microsoft uses. But there's a standard that Microsoft created when both .NET Core and .NET Framework existed that's called .NET Standard or the .NET Standard. And it's not another runtime. That's one thing that I think throws people off. They think like, is this just yet another flavor of .NET that can be running in different places? And the answer is no, it is not another flavor of .NET. It's a standard that different versions of .NET can comply with different versions of the standard. The reason that that's beneficial is you can take a class library like this that's meant to be shared across .NET Framework and .NET Core, and you can compile it against .NET Standard, and then use that same compiled class library on any flavor of .NET that you want, as long as it supports that particular version of the standard. So let's actually do that upgrade one more time. And I'm going to come in here and pick upgrade again and do an in-place upgrade. And actually, you know, I'm actually going to roll that back because I don't have the option to do what I want to do right now. So let me actually just unload this. Let me close the solution. And then I'll go to my Git tool, and I'm just going to go ahead and roll back those changes. Easy to do when you have Git, right? And then I'll open that back up again. So now if I go into this, it should be back onto .NET Framework 4.8, just like we had it a minute ago. No harm, no foul, right? So now I'll pick Upgrade. But this time, when I pick In Place Upgrade, instead of .NET 8, I'm going to pick .NET Standard 2.0. So this is only available when you're upgrading class libraries. That's something to keep in mind. And if you look it up on, Microsoft has a help page on learn.microsoft.com that'll tell you what different versions of .NET Standard apply to what different versions of .NET Framework, .NET Core, Modern .NET, and you can kind of pick the one that's right for your particular project. I happen to know .NET Standard 2.0 will work quite well with 4.8, and I think it goes all the way back to maybe 2.5 or 3.0 of .NET. So I know that that one will work quite well. So I'm going to go ahead and upgrade that way. All right. And let the .NET Upgrade Assistant finish. You can see we got all of our green checks again. And now if I go into my project properties on the class library, you see it's .NET Standard 2.0. And now if I run this again, what we'll see here is that this class library works exactly the same way. When it gets loaded into the ASP.NET application that's running against .NET Framework, it'll actually run against .NET Framework. And when later in a minute, when we create the ASP.NET Core application, the modern one, when this class library runs against .NET Core or Modern .NET, it'll run there just as well. So that's kind of the advantage of .NET Standard. So here you can see everything running as before. Okay, so that's our first step. Now the next step is going to be the hard one. I told you web projects are the harder part. So let's actually look at doing that upgrade next. I'll go here and say I want to upgrade the web project. Now you see it's a slightly different set of options. I've still got the CPM and the SDK style options down at the bottom. But when it comes to upgrading to a new version of .NET, I only have one option, which is what's called a side-by-side incremental project upgrade. And if you read through that description, you'll see it'll describe ASP.NET Core, ASP.NET, and then YARP, which we were just talking about a minute ago, as being part of how it's going to approach this solution. So that's what we actually want to do. Now, it could be that you've already created your modern ASP.NET web application, ASP.NET Core web application. In that case, you could pick existing project. In our case, we haven't created the modern web project yet, so we're going to say new project. And I want to change its default name here and say, let's replace this word legacy with eShop Core MVC for the new app. Okay. Now you'll notice when I get to pick what .NET Framework version, .NET version I want to run against, I get versions of .NET, but I do not get .NET Standard. Hopefully you understand by now why that is. This is not a class library. This actually has to run against some version of .NET. And so at runtime, it's going to run against .NET 8, let's say. Let's go ahead and pick .NET 8 as the long-term support version. It's going to give me a bit of a preview here about what steps it's going to take for me. And I'll click Finish. And it's going to step through all of the steps in that process and make some upgrades for me that it can automatically. You see I get all green check marks. Interesting thing though, this actually went a bit faster, I thought, than the class library did, even though I told you web projects are more complicated. There's a reason for that. It didn't do as much for us as it did with the class library. So if we actually look at what it did do, the important thing here is that I've now got my legacy MVC web application, and I have this core MVC web application, which if I go look at the properties, for this one, you'll see it's running on .NET 8. The other things that it's done is if I look at you'll notice it's pretty much an empty project at this point, except if I look at the program CS, HTTP, add HTTP forwarder is in here. So this is the pipeline, right? So this is adding the middleware for YARP. And then down here, you'll see map forwarder in the configuration section. And this is actually configuring YARP. And you can see it's basically got kind of a wildcard path in here that's called catch-all. So this is built into YARP and how it works. This is you could think of this as just a wildcard path. So it's basically saying anything that matches anything will get forwarded to, and then you can see the proxy to is coming from a configuration setting. And then there's just some additional routing here as far as prioritization goes. So I can have multiple rules that have different priorities. So it's a very simple rule. And this is what I showed you in that diagram earlier, where it's going to look at the routing table. And if it exists in this app, it'll route it to this app. Anything else, literally catch-all, is going to go to the legacy application configured at this proxy2 address, which we can go look at in our it's not in our app settings, it's actually in our launch settings. So you'll see the proxy2 is that 50295. That was that port number we saw before on the legacy application when we ran it. And we can also see that our app is actually, our modern app is going to run on a 4-digit port here, 7195. The other thing, which I think is kind of cool that it does, is it actually changes your startup projects. So if I go to configure startup projects now, you'll notice that both the legacy and the core MVC app are both configured to start when I start the debugger. And that's for obvious reasons that both of them need to be running for the modern app to work because it needs to be able to forward. But if I actually look at the settings now on my legacy app, under the web settings here, you'll notice that it has no start page configured anymore. So basically, it's going to start it, but in the background, so that I'm not going to see this pop up. I'm only going to see my modern app pop up. This will be running in the background. The modern app will be running and in the browser. So let's actually run this and see what we see. Okay, so now I see the console popping up because this is an ASP.NET Core application, so it runs through the console. And you notice that port number, 7195. And you notice the application comes up and runs. Now, it took just a smidge longer. That's not because the application is going to always be slow like this. It's because it took my computer a little longer to launch 2 web applications and attach them to the debugger at the same time. But now if I interact with this project, you can see it interacts basically the exact same way as the legacy application did before. Just now it's all being proxied through the modern app. So now I can go to my boss and tell him the legacy migration is done, right? Yeah? Okay. No, not quite, right? Really, we've just taken step 1 of what's going to be a long journey. I want to show you what step 2 looks like, and then you're going to have N more steps after that, right? You're going to have to basically solve all the problems. You're going to have to do each particular endpoint one by one, figure out how to solve the problems that that endpoint maybe has with NuGet packages and system.web code that doesn't exist anymore and all those types of things. But this is how you're going to migrate. When you do migrate something, you might pick a particular controller if you're using MVC, like the system web controller I showed you earlier. And you can see I can actually right-click on it now and pick Update Controller. Or what's kind of cool is if I go to this legacy project and pick Upgrade again. I got to say I'm done with it first here. When I go to Upgrade now, I'm going to see a slightly different user interface on that project. Now I see essentially the real truth about how much of my project has been migrated, which is 0, right? Over here you can see .NET Framework has 15 endpoints, it's 100%, and .NET has 0, which is 0% of my application has been migrated so far. So this is actually a great place to come back and see what my progress is on this migration. Now I'm going to actually go down to that system web controller, and I'm going to do the Update Controller option here. And it's going to say, here's all the things that I found that are connected to that controller and its endpoints. That includes some views, some shared views, things like that, that it's going to have to migrate as well. And I can say, yes, go ahead and do all of those. Okay. Now, immediately, I start to get some errors. And this is basically because my modern application that I just migrated things to has no reference yet to my class library. So I'm going to go into that and fix that problem by just going in here and adding a project reference to my utilities class library. All right, and now if I do a build, it's going to fix most of these errors, except, and this is a thing that I've purposely left in this demo that doesn't work smoothly because I want to show you, the .NET Upgrade Assistant is a 0.5 version right now. It is not technically a full release, and so it's not perfect. It helps with a lot of things, but I purposely wanted to leave one line of code in here that it does not handle correctly. Anybody remember what was happening here before? We were setting a viewBag property to the results of that class library call, and so what this should actually look like, and it converted it incorrectly, is it should just be viewbag.userAgent equals like this. And now it's basically the same as it was before. So it just basically misread that line of code and misunderstood what was happening there. Now I should be able to build this. But it takes longer when everybody's watching. So look away for a second. Okay, so one line of code. Oh, did it just fix? No. Yes. Yes, yes. So now here's where the fix for the system.web comes in that I mentioned earlier. So if I go to my core modern application and I manage my NuGet packages here, and I type in system web, and system web, let me type in adapters. Here we go. So you see I've got this class library, a NuGet package called Microsoft ASP.NET Core System Web Adapters. This is essentially a class library that Microsoft wrote, compiled against the .NET framework, and they wrote it in such a way that it's basically every method has like a big if statement in it, you can think of it as, that says if I'm running in .NET Framework, go run these system web things from here. If I'm running in .NET Core or later, then run these things from where they exist now. So you can basically keep all of your system, it's about 80% of the SDK right now for system.web has been moved over into here with just basically code that forwards it to the correct place depending on where you're running. So I'm going to go ahead and add that to my modern application. And then I'm going to add the system web adapters also has a framework services, which I'm going to add to my modern, or to my legacy application. So I'll go here to my NuGet packages and do system web adapters again. And add that. Okay. Oh, that was just a clean. Let's do a build. And now from here, I can basically actually run my code. Hopefully this build actually works. Yes. Now I should be able to actually run my code, and that particular system.web endpoint will now be running on the modern application, and it should be invisible to me as an end user. Oh, of course. Yeah, so this It basically happens because when I reset the Git repo, sometimes the code gets in the bin and obj folders, gets a little messed up. So without making you watch that, you can trust me that it actually works when you run it. But the system.web endpoint will now respond to any request that comes into the modern application without forwarding it to the legacy application. But if you think about that particular page, it has the layout that's now been migrated, but it also has some JavaScript and some CSS. Those are coming from bundles in the legacy application. And all of those things should probably be moved over next, right? So that's a whole other set of things, because those bundling options don't actually exist in ASP.NET Core anymore. But there's libraries such as one called LigerShark that will actually do bundling in very much the same way. If you want to look at my Git repo after the talk, you can see that I've actually gone to this next step, and I've moved all of the CSS and JavaScript over into new bundles using this LigerShark library that bundles them server-side, and moved that entire page over so that then you could move on to the next controller, and all of that JavaScript and CSS for the entire app will now be moved over to the modern app as well. But since we're running a little tight on time, I don't want to show you that right now. So just to kind of wrap up, you've seen a migration happen. I mentioned the system web adapters. These can help you with things like with security as well. Session state. If you have a bunch of session state stored in your application, and you need to share that with the modern application as well, you can actually set it up so that it's stored in the legacy app, and the modern app can call into the legacy app and get that information. This is a diagram that Microsoft made for about how security can work. So you can actually have your login synchronized by basically when the user tries to access something, the header that they send will get forwarded to the legacy application that has an endpoint on it that will answer that, and back to the modern app and say, here's all the claims that come with that particular user, and now your modern app can know everything that the legacy app knew about that user, but without having to write a bunch of code that goes and does that from your user store or your database, wherever your users are actually stored. So I mentioned that some of these things are in release right now. YARP is on version 2.3, so this is very much production ready. System web adapters is on version 2. This is very much production ready. The one thing that we looked at today that is still very much in flux and is getting new stuff added to it all the time, but isn't really something that you run in production. It's the tooling that you use for development, the .NET Upgrade Assistant. So just be aware that this is a version 0.5 point something right now, and Microsoft is actively developing it. They're obviously adding some AI features coming very soon, which shows that they're excited about it, but it's not done yet, so it's not fully baked. Well, that kind of takes up all of my time, so I will stick around and answer any questions anyone has. Please feel free to reach out to me at these places as well if you'd like to. Thanks so much for coming today.
Is there an easy guide to set up YARP without the .NET Upgrade Assistant?
Yes, great question. So you can actually do this all without the .NET Upgrade Assistant or without the .NET CLI. And it's really pretty simple. You basically add YARP to your modern application as a NuGet package. And then you add those 2 lines of code we looked at in the program CS, the catch-all mapping statement, and then the other one to actually add it to the pipeline up above. And you're basically done. So it's really that simple. If you would like to look at a project, you can look at the one that I did as a starting point. You can also just do file new project and create a new .NET Framework ASP.NET application, and then do a migration on it and see the code it generates. And you'll see there's basically 2 lines of code and that NuGet reference, and that's it. So very simple to add.
The catch-all is just a fallback, so you don't have to add new routes yourself manually in that file.
Yeah, that's right. This is all, what you saw is all basically default configuration, so you can change how it works. But what you saw was configured for it to use the routing table, and then to use the routes that I configured, that being just that catch-all rule. as a backup after it looked at the routing table.
Kind of to follow up on that, is it possible, like for a back-end controller, to migrate based off of method type and/or additional routing on that specific controller?
Yes. If you use the upgrade assistant, it's going to kind of be a little all or nothing when it comes to class files. But if you do it manually, you can do it however you'd like. Yeah, absolutely. Well, thanks so much, everybody.
Thank you.